list your x and y intercepts. The x-intercepts are going to be, you're going to have a number first and then 0. For your y-intercept, you're going to have 0 first and then a number. Raise your hand if you can tell me where the x-intercepts are for this graph. This one has 2 x-intercepts. Can we please take out our earbuds, please? Earbuds. Thank you so much. I appreciate it. Okay. Can someone tell me where my x-intercepts would be on this graph? Is it Lariah? Yes, ma'am. What would you put? Thank you. Anyone else get that? -2, 0, and +2, 0. All right, this is my x-axis, and my x-intercepts are here and here. All right, our y-intercept, there's only one, and it's about right here. Who wants to take a guess? Where would you put, what did you put for the y-intercept? 0, -4. All right, go ahead and get out your notes and go to page 7 in your note packet. So page 7 in the note packet, we have some definitions to copy down. Oh, not copy down, sorry. They're already there. So today we're going to talk about looking at a graph and finding our maximums. So there's 2 different types of extrema. So graphs of functions can have high and low points where they reach a maximum or a minimum value. The maximum and minimum values are called the extrema. So the maximum is the highest point on the graph, and the minimum is the lowest point on the graph. So there's 2 different types. So for the absolute extrema, when you think of absolute, I want you to think of it's the highest or lowest point. But a relative extrema, I like to think of it as hilltops and valleys. So it's not the highest or the lowest, but it's a place in the graph where you might have a dip or a peak. So a dip or a peak. And we're going to look at 4 graphs today and determine where these extremas are located. We're going to determine if it has one, and then we're also going to determine if it's an absolute or a relative. So before we get started, I want you to write this down. I don't know where we can squeeze this off to the side, but if you see an arrow going up, so if graph, let me write this out. All right, I'm gonna write it. I'm gonna squeeze it in here. If the graph has an up arrow, that means it has no absolute max. So I'm abbreviating that. So if you notice that the graph has an arrow that points up, it doesn't have an absolute max. And the reason why is because it's never going to stop going up. So if you never stop rising, you'll never reach the top. Okay? If a graph has an arrow going down, that means it has no absolute min. And the reason why is because if it continues to go down, it's never going to reach the bottom. So it is possible to have a graph that does not have any absolutes, especially if you have an arrow that goes up on one side and an arrow that goes down on the other. So I'll give you a minute to copy this down, and then we'll look through some graphs. Okay, so let's go ahead and look at example 1. So looking at this graph, first thing I notice is it has 2 arrows that point up. So what does that mean? If it has 2 arrows that point up, that means it has no what? Let me go back. Which one doesn't it have if you have an arrow that points up? No absolute max. So I already know that because both sides are going up, this graph has no absolute max. I'm going to write that down. No absolute max. So this graph it also doesn't have a peak. So this graph has no maximums at all. It has none. But it does have a place that we can call your lowest point. And where is the lowest point on the graph? Right here. Well, it's a little, let me zoom in. You can kind of see that it's kind of in between, halfway between -4 and -6. So about -5. So -5, 0, -5 is your lowest point, and there is no point lower than that. So that is called an absolute minimum. So go ahead and circle absolute. Any questions about how we did that? All right, let's look at another graph. So the first thing I'm noticing right out the gate is that one side goes up. We have an arrow that points up, and I have an arrow that points down. So because I have an arrow that points up and an arrow that points down, I know that I have no absolute max or I also don't have an absolute min. So this graph doesn't have either one of those because we have an arrow on one side that's going up and the arrow on the other side that's going down. But when you look at it, do you notice that there is a place where you have like a mountaintop? And let me go ahead and zoom in. This is like a peak. Go ahead and put a point right there. That's a relative max. Now, it's not the highest point, but it is a peak in the graph. So let's go ahead and name that point as an ordered pair. So this point occurs at x equals -2. Y is equal to what right here? 8. So at relative max, I want you to write, where it says max, I want you to write -2, 8. And we're going to circle that that is a relative, not an absolute. Now, when you look at the graph, do you notice that there is a place where it dips? Do you see the dip in the graph? It looks like I don't know another word for it. But right here, go ahead and put a point right here. That is a relative min. Now let's go ahead and label that point, and that would be at 0.4. And that is a relative minimum. And that's it. So if you see arrows that point up, you don't have an absolute max. If you see an arrow that points down, you don't have an absolute min. If you have an arrow that points up and down, that means you don't have an absolute max or min. All right, 2 more graphs. Let's go ahead and look at this graph. Can you go ahead and add arrows, please? Because I forgot to add them. Add arrows. And then can you also, down the side, list. We're going to write relative min, and we'll abbreviate. Relative max, absolute min, absolute max. So what I'm noticing is that I have an arrow that points up and an arrow that points down. So which two can I automatically cross out that we won't have? We won't have absolute max or min. So what I want you to write on those 2 lines is I want you to write none, because we don't have either one of those. Now, I do see a place where there is a dip in the graph, though. Would you agree right here? It's kind of like a dip. That's called a relative minimum. So go ahead and put a point right here and call it relative min. It's a dip in the graph. Now we have to kind of approximate where this is, because it looks like it's about -3, maybe -3, negative, we'll round it to 200. It's a little bit above 200, but we can round it. That's okay. And that's a relative min. And then there's also a place, do you see the peak or the mountaintop? That would be about right here. Go ahead and put a point. And that's called a relative max. And that looks like that is about at +3, 200. All right, last graph. So add your arrows. And let's go ahead and write it out to the side. We have relative min, relative max, absolute min, absolute max. All right, only one, well, this is kind of tricky, but do you notice how we have 2 arrows that point up? So that means that we don't have an absolute max, so we can say none. Now we do have a relative max, and that would be right here. You see this little mountaintop? That's called a relative max. So go ahead and put a point right there. Name it relative max. That looks like that is approximately located at 0.30. And when you see this on your test, next Friday is your first test. Next Friday, September 1st, yeah. You're going to approximate the best you can. All right, now these two, and we're going to do some more examples tomorrow, but it's difficult to tell which one of these is lower because they look like they come down at the same point. So we're going to call both of these an absolute. So we have an absolute at -320. And at +320. And we don't have a relative min. Okay, so now we're at the place where on homework 2, you can do question 4. So everyone work on question 4. If you need help with it, feel free to come up. I can help you with that. Tomorrow we're going to finish this out, and you'll be able to finish all of homework 2. I'm going to check homework 2 on Wednesday.